Hello, this is Dr. Liu. In this video, I will explain how to read a temperature probe from a 4 to 20 milliamp temperature loop. So in order to do this, first you need a temperature probe, and also second you need this transducer, and then also you'll need an SDI12 USB adapter with a 4 to 20 milliamp current loop sensor extension board. So let's take a look at this transducer. It needs this particular sample signal from this is PT100. It's a platinum sensor probe, and it wants these three wire connections from the sensor to this transducer, and it'll only take temperature within 0 to 100 degrees C, and it'll convert that into a range of 4 to 20 milliamps. So that's what it does. It reads that temperature range and then it converts into this current range. So let's see how to get the temperature back once we read the current. So the current has this range, 4 to 20 milliamps, and temperature has this other range, 0 to 100 degrees C. So if you take the current readout and then subtract the 4 because 4 is the starting point. So once you subtract the 4 and you divide by the range 20 to 4, this is a 16 milliamp range. So you minus the initial. So how far are you along this range is calculated in this fraction. So then you want to recast that into a different range with the temperature range. It is the high temperature 100 minus low temperature 0, and then you multiply these together, you'll convert current into temperature. Okay, so how do you do it with the 4 to 20 milliamp extension board? Well, the extension board does not report current. It actually reports voltage just for compatibility with all the high resolution analog extension boards and the analog inputs. So it reads voltages. And all you have to do is to take that voltage and multiply it by 10. Okay, so once you multiply the voltage by 10, you get current in milliamps. So that's the current in milliamps. And minus 4 is because your current starts at 4. And then divide by 16, that's because your range of current is always 16 milliamps apart. That's a 4 to 20 milliamp loop. It always does that. And then you multiply this 100 to rescale your current into temperature. So here's an example. If your voltage readout is 0.833 volts, then you multiply by 10. This is your current now. And then current minus 4, that tells you how far are you from the starting current 4. And then you divide by 16, you have a scale of where you are within the 16 milliamp range. And then you multiply this 100 to turn this whole thing into temperature. So you're at 27.1 degrees C. So what if you have a different transducer? Okay, so here's another example. A different transducer that goes from minus 50 degrees C to plus 150 degrees C. It also requires the same signal from a PT100 and outputs 4 to 20 milliamps. So here we have a different temperature to map. So minus 50 to plus 150 from the 4 to 20. So we do the same thing. We take the current readout, subtract the starting point, and then we divide by the range. This gives us where we are at in our temperature range. And then we multiply this, which is the target temperature range. So the temperature range is 150 minus negative 50, or 150 plus 50. And then we must also add the starting point, because this whole thing only gives you where you are at within your range of 200 degrees, but your starting point is minus 50 degrees C. So that gives you the result and the temperature. And again, if you're using my 4 to 20 milliamp extension board, then the voltage you read multiplied by 10 is the current. And then that current minus 4 divided by 16, that's converting that into a fraction of a range in current, and then multiply by 200, then minus 50. So if we take the same readout, I don't really have this transducer. I just have a photo here. So if we take the same readout and then we convert that, and it turns out this is actually 4.1 degrees C. So I bet if I do have this and I put that sensor outside, you'll probably show this. On the other hand, the previous readout, this one here, let's go back one slide. Doesn't really want me to go back one slide. Anyway, so the previous one with this that calculates into 27 degrees C, that was just my hand touching the sensor for a little bit, getting the sensor warm. Thank you.